So, hello. Today we will talk together about quite interesting topic. Yeah, as usually it's SSI, yeah. And in SSI or Web3 world, we always have a challenge of the identity, and different people try to use it with the different standards. But usually when we talk about the identity and SSI, usually the DIDs pop up as a solution for everything. First of all, we need to understand a couple of things, that we have hundreds and hundreds of DID methods. Some of them are on-chain, some of them are off-chain. It's not so much of off-chain methods, and we have some good reasons for this. It's quite hard to design the protocol in a secure way when you don't have something that you could cryptographically prove. And the correlation with the blockchains and DID methods, it's not direct. So you could have a couple of hundreds of different DID methods based on the same blockchain. But then what usually makes me worried that every time when we talk about the Web3 or Web5 or decentralized world, we usually mean something on blockchain. It's not really true. So today we will talk about mechanisms that still decentralized but could be off-chain, and what kind of problems they usually solve. So one of the completely decentralized solutions that give us, for example, distributed storage, it's APFS, and it's quite crucial, and it's quite crucial for some systems that we will discuss today. But another one is the decentralized systems that allow us to communicate between the DIDs. And here we already discussed on my previous video how we could organize the exchange protocol on top of DIDComm. And actually one of the ways of build the decentralized world is to build a decentralized messaging between the DIDs, that you have your DID, so you have your identity, and now you want to talk to somebody else that have this identity. And most primitive and easy way to do it is build the authorization on top of DID, and it's extremely simple, that one authority sends some cryptographical challenge together with the DID, and the another side just encrypted with their private key, and your public key give it back, and another party could decrypt it and actually give the authorization token. It's already good enough, but it's not giving us the protocols that allow us to describe the communication itself. And here the DIDComm help us. So DIDComm define the message format, what kind of messages we could exchange. Is it encrypted? Is it signed? Is it plain text message? How we could exchange the cryptographic information between these messages. And actually DIDComm version 2 is quite powerful, but you need to understand to talk with the DIDComm, your DID document should contain the service section, not just public key, but service section that describe where the DIDComm friendly node is located. And another thing, that in DIDComm you have two different types of routing. You have the network routing and you have the cryptographic secret exchange routing. So that's why you usually together with the endpoint have something like key exchange. So there's the negotiation between 2 points, how they could exchange the secrets. And here we need to understand one thing that majority of people miss, that your DID documents is not just public keys, it's quite complex cryptography that stay behind these public keys. So if you're another party simply don't understand this public cryptography, they are not able to communicate with each other. That's why they should match on the capabilities how to understand the cryptography of each other. So DIDComm is quite cool. On top of DIDComm you could already build a lot of different protocols, but DIDComm have quite basic concept like messages, thread of messages, some authorization mechanisms, and it's already good enough. But yet another way another specification that allows us to make communication between two endpoints and DIDs actually is the Decentralized Web Node. It's relatively new specification. It's still under active development, and the first reference implementation will be somewhere this September. They quite similar to the DIDComm, I would say, because they use the service endpoint in a DID document and all other things, but the benefit that it's more high level, so it's not just design of the messages. You have some concepts and you have some capabilities that more application level. So you have the messages, you have the threads, you have the collections, you have permission layer on top. And every node able to negotiate what kind of features of the standards they support, so they have the discoverability. And the coolest part that you could not just send the message to another DID, you could actively query their own collections that they expose to you, or you could actually give some permissions to other people to interact with your data. So it's quite powerful distributed protocol that, based on the diddocs, describe the formats of the messages and describe the how we could store them in IPFS. So it's, I would say, full stack that describe not the implementation, but how we could interact, what kind of messages, what kind of responses, how we could store, persist these messages in a distributed storage. And I believe that we will have much more protocols like that. So, and currently we have diddocs, DIDComm version 2, and distributed web nodes. So maybe we will have more emerging protocols like this. For example, from our side, we implement something that called the messaging, and for this you don't need to modify your DID document. You could just talk with two DIDs that already exist and just expose the public keys. So it's a messaging service. You could take a look to our specification. So I believe that this peer-to-peer communication is a future. That's why we will see more and more DID methods and the protocols on top of DID methods that will do it. Stay with us, subscribe to our channel, try our SDK, and yeah, just let me know what you are doing in this space. I will be happy to give you more information and learn from you more. See you.